Okay, this is question on page 67. 67 on your workbook. So let's read this question first. A bullet travels 0.80 meter in the barrel of a gun and leaves the muzzle within 0.0050 seconds. So question A asking what is the velocity of the bullet? Actually, it's upon leaving the gun. And then how high would the bullet go if it were fired straight up? Okay, so look at this question. So we try the step one. Let's try to draw a VT graph. Okay, velocity and time. So it is implied the bullet initially having a zero velocity. So initial velocity must be 0. And then it travels with constant acceleration over that much distance. So you should have this kind of graph. So here is the time, should be 0.0050 second, and the velocity, final velocity, we do not know here, but it is the final here, which we need to find it out. And then it says it travels 0.80 meter. That's actually this area here. So area here would be 0.80 meter. Okay, so that's give you a better understanding about what's the information given. So you can use the graph to help you to understand, or you can just simply use the graph to solve the problem. But let us find out to write a list of information given. So according to the graph, you should understand we have initial velocity 0, and then the final velocity we don't know, and acceleration we don't know, but we know the time equals 0.0050 seconds. We also know displacement is 0.80 meter. To solve this problem, I like to use the basic formulas. So the basic formula is V final, V average velocity equals V initial plus V final divided by 2. And the other formula is displacement equals average velocity times time. Now you can tell we know the D, we also know the T. So it looks like we can find out the average velocity. So average velocity would equals D over T. You can get 0.80 meter over 0.0050 second. So we leave this here. So okay, sorry, this is average velocity. And then because average velocity equals V initial plus V final, so we can plug in here. So 0.80 meter over 0.0050 second. That's the average velocity we just got here from here. And then it equals V initial, which is 0, plus V final divided by 2. Okay, solve this equation. You should be able to get V final equals 320 meters per second. So you can tell all the information given are 2 significant digits. So and then you have 320, that looks like 2 significant digits, so it's perfect. Okay, so that's for A. So we just solved A. And then look at B. How high would the bullet go if it were fired straight up? That's actually, this graph is actually for A. And for B, we like to draw another graph. Okay, so it's also a VT graph. T. So the B is the situation when the bullet goes fired straight up, and then it should continue to go up, but it's slowing down, and eventually the velocity will become 0 at the highest point. So you have initial velocity, actually 320 right here. So we do have the initial velocity, and finally the velocity becomes 0 at its highest point, right? So the question is asking for how high, and it must be asking the area, right? So let's label the 320 here, that's as initial velocity, and the final velocity, actually you can tell from here the final is going to be 0, and this is the initial. And also you need to know the slope. The slope is actually equals acceleration, and for a free fall, right, when something in the air, it always having the acceleration 9.8 meters per second squared. And we need to explain this. It looks like the slope here is going to be negative, so obviously it's negative. And the reason it's negative is because we take the initial velocity going up as positive. See, we put a 320 as positive 320, and then because acceleration is going down, so it's against the direction of initial velocity. So that's why the A is negative. Okay, so let's come back here, make a list of information. Actually, a lot of information already labeled on the graph. So initial velocity 320 meters per second, and which is actually the final velocity for when the bullet's inside the gun. Okay, and then the final we also know is 0, and acceleration equals negative 9.8, right, meters per second squared. So the question asking for find the displacement D. Okay, to find out the displacement, we can also rely on this couple basic formula, plus the other formula is acceleration equals V final minus V initial divided by T. So from this formula, you can find out the time it takes for the object to rise to the highest point. So if you isolate T, the T should be V final minus V initial, then divide by the A. Okay, if we plug in 0 as the final velocity, 320 as the initial velocity, divided by negative 9.8. So this is going to be the time. We don't need to calculate here, but we can certainly write it as 320 over 9.8. The unit is of course second, and then we apply so look at this formula. We need to find out D, so we already got the time T, and the average velocity you can also find out using this formula. So, and then average velocity equals v initial plus v final divided by 2. So obviously this one equals 0, 320, let's start with initial velocity, plus 0 final velocity divided by 2. So we should get 160 meter per second. Now we are ready to find out the d. Okay, so the d equals average velocity times time, and then just times these two numbers together, 160 meter per second and times 320 over 9.8 second equals, so equals, if you look at your calculator, you should get 5224.48, right, and so on. So because you're supposed to keep 2 significant digits, so let's do this. 5.2, use scientific notation, times 10 to the power of 3 meter. Okay, and if you're interested, you can actually solve both A and B graphically, right? You can certainly try.